All right, everybody. So here we are at our Phet simulation that you guys are going to do your first assignment with. So the very first question asks, open the models of the hydrogen atom Phet. That's what this is. Click the experimental control. That's up here. Got it clicked. And then it asks, what are some of the things that we can change? Okay, so the first thing that I can change, obviously I can turn on and off this light that I'm passing through this box. I can change it from white light, or I can change it to monochromatic, where I can do like a specific color one way or the other. I can do red, but we're going to leave it on white for right now. And other than that, that's pretty much all that we can change on this. So play with the simulation, but stay on the experiment option. Record your observations. So things that I want you to notice. I want you to notice like what kind of these lights are getting, let's say, repelled inside this box. So you'll notice that you'll see most of them going straight through this box, but every once in a while you'll notice that things get shot back in different directions. Okay, so for example, oh, there went one right there. There went one right there. Let's see, we got another one. Okay, but notice that things are being repelled inside this box. And so what we're saying is that this is a box of hydrogen atoms, okay? And so things are going inside there, but then they get repelled. Okay, so then that leads to question number 3. Why do you think there is a box hiding the H atom? Okay, so what I want you to think about is hydrogen. What do we know about hydrogen that would lead to us having this question mark? Okay, again, if you guys have any questions about any of these answers, remember to drop into my office hours. Tomorrow it is Thursday, so I'll be on from 8:30 to 9:30. Friday I'll be on from 2 to 3. Just pop in, ask your question, I'll answer it, and you can be on your way. Okay. Let's see. Number 4. Why is there a disclaimer that says drawings are not to size? Okay, or not to scale, right here at the top. Okay, well, think about atoms for a second and think about how big atoms are. Okay, that will lead you to that answer to that question. What do you think the little objects being emitted from the gun represent? Okay, so all these little ones, so let's see where they're right there. Okay, something just got emitted over there, something just got emitted up there to the left. Okay, but all kinds of things are getting emitted. Think about what objects, okay, are being emitted from this box. Okay, well, moving on. Okay, make sure that throughout this whole thing that you can in fact pause, okay, to answer a question. I'm just trying to go through this whole thing in one swoop. So if you need to stop it and then write your answer or type your answer, feel free to do so. Make sure again that you're uploading this to Teams after you're done. All right, so next we're going to go into the prediction mode. Okay, so that's where different models are in here. I'm going to turn the light off for right now. And basically what you're going to be doing is you're going to do a description mentioning protons and electrons if they're present in that actual model. A picture. Okay, now for a picture, I'm actually going to have you guys skip that one because obviously you guys aren't going to be able to draw anything on these. So do not worry about the picture section of this assignment. I'm not going to worry about that. What happens when the light is off? What happens when the light is on? Okay, so let's start with billiard ball. And all I'm going to do is I'm just going to let these play and I'm going to let you make the observations. Okay, so I'll let them play for about, I don't know, like 45 seconds or so, and you can make your observations and you can answer your questions. So we have the billiard ball. We turn the light on. Okay, so that's with it on. This is what it looks like when it's off. All right, moving on to plum pudding. Okay, again, remember plum pudding is where this red stuff is going to all be positive material, and the blue here is going to be our lone electron. Okay, so make your description first, and I'll turn the light on. All right, so that's what it looks like with it on. Here's what it looks like with it off. As you can see, for most of these, when the light is off, nothing is going to be happening. Okay, let's see. Let's move on to classic solar system. Okay, so that's that. Let's turn the light on. Maybe I can reset it. And you'll notice that, yeah, I'm not going to get a whole lot of action here. Okay, and then if I turn the light off, perfect. Okay, so then we have the Bohr model. Okay, so here's what happens when the light is off. Okay, make sure you also make your description. Don't worry so much about the picture. Okay, and I'll turn the light on. Okay, making sure that you notice what's happening to the proton and what's happening to the electron. Perfect. Okay, moving on to, again, this is the wave model. Okay, the wave model that goes with de Broglie. Okay, you'll notice that the wave motion of your electrons. Okay, so that's what it's like with it on. And here's what it's like with it off. Okay, moving on to the last one, Schrodinger's cloud model. Okay, electron cloud model. Turn the light on. Okay, so it's affecting the electron clouds in here. All right, so that's what it looks like with it on. And if I turn the light off, that's what that looks like. Perfect. Okay, so we've gone through all the experiments. All you guys need to do is answer the last 3 questions. What are the similarities and differences between the models? How could we describe the properties of a photon using physical variables, color, size, speed? How it changes the atom itself? Okay, so if you imagine what we mean by photons, photons are just particle of light, so that's what I'm firing at this atom. Okay, so what physical variables, colors, and that sort of thing might change how it affects the atom. Okay, again, if this isn't making sense, come into my office hours and we'll talk about it for a second. Okay, and then lastly, what is our current model of the atom? Which, if you watched my first video, you should already know what that is. After this, this is all I need you to watch, and make sure that you submit this assignment onto Teams. Thanks for watching, guys.